Саламатсыздар ма, құрметті студенттер? Біз алгебра есеп және шешу практикумын ағылшын тілінде жалғастырамыз. Бүгінгі сабағымызда біз көпшілік түрінде жалпы сызықтық емес теңсіздіктер мен рационалды теңсіздіктерді шешудің әдістеріне тоқталатын боламыз. So, we get consider polynomial and rational inequalities. Let's get started. After these lessons, students will be able to solving polynomial inequalities and rational inequalities. A polynomial inequality is a mathematical statement that relates a polynomial expression as either less than or greater than another. We can use sign chart to solve polynomial inequalities with the one variable. So our main method is we using sign chart method to solving polynomial inequalities. Graphs are helpful in providing its visualization to the solution of polynomial inequalities. Examine the graph below to see the relationship between a graph of polynomial and its corresponding sign chart. So, to solving any polynomial inequalities, we use this algorithm. First, rewrite the inequality so that is a zero on the right side of the inequality, the expression on the left side designated as f of x. Design it. Next, find the critical numbers. Critical numbers for polynomial functions are real numbers solution of this equation, f of x equal to 0. Draw a number line with the critical numbers, label it. Draw an open circle at each critical numbers if the inequality uses less than or greater than. Draw the full filled in circle at each critical number if the inequality uses less than or equal or greater than or equal. So create the sign chart, the critical numbers, partition the number of line into regions or divides the number line into regions. Choose the test value for each region, including on to the left of all the critical values and on the right of all critical values. For each test value v, determine if f of v is a positive or negative and record the result on sign chart of each region. And next, use the sign chart to find the set of all values of x for which inequality is true. Write the answer in interval notation. So consider this polynomial inequality with the power of 4. So begin by finding the critical number for polynomial inequality in standard form with 0 on one side and critical number are the roots because fx is equal to this equation given its factorial from the roots are apparent. So we find critical numbers by equalizing this function to 0, and here the roots of this equation is -3, 0, and 4. Because a strict inequality plots them using open dots on a number line. So in this case, the critical number partitions the number line into 4 regions. So we divide the number line 4 regions. Test values in each region determine if f is positive or negative. Here we choose the test values. For this, we choose these values from these four regions. In the first region, I take -5, in the second, -1, in the third, 2, and the last region, I take 6. Remember that we have only considered with the sign plus or minus of the result. By plugging -5 into this function, we find the sign of this function in this region. So by evaluating this means, we find that in this region the sign of the function is positive. So repeating this process for the numbers -1, 2, and 0, and 6, we find signs of each regions. So it is a mistake. So it will be negative. It will be not positive. It will be negative. So the question asks us to find values there where f of x less than 0 or the function is negative. From the sign chart, we can see that the function negative for the values x from this interval, certain interval, from interval from 0 to 4. So so the solution of this inequality is equal to 0 to 4. So next we consider how to solve rational inequalities. A rational inequality is an inequality that contains rational expressions. To solve rational inequality, first write the inequality as one quotient on the left and 0 on the right. Determine the critical points, the point where the rational expression will be 0 or undefined. Use the critical points to divide the number line into intervals. Test a value in each interval. Above the number line shows the sign of each factor of the numerator and denominator in each interval. Below the numbers line show the sign of the quotient. Determine the interval where the inequality is correct. Write the solution in interval notation. So according to this algorithm, we solve this inequality. So first we must determine critical points, the point where the rational expression will be 0 or undefined. The rational expression will be 0 is x equal to 0, then it is 1 is critical point. The rational will be undefined. The denominator is equal to -3. It is also critical point. So this inequality has two critical points, 1 and -3. Use the critical points to divide the number line into intervals. Test a value in each interval. Above the number line shows the sign of each factor of the rational expression in each interval. Below the number line shows the sign of quotient. To determine intervals, the inequality is correct. Write the solution in interval notation. So recall that we can have the solution made of more than one interval. We use the union of symbols to connect two intervals. So the solution in the interval is from -infinity to -3 and from 1, including 1, to positive infinity. So next consider this rational inequality. So subtract 1 to get 0 on the left, on the right side. So we move this 0 to the left to get 0 on the right side. So rewrite 1 as fraction using LCD and subtract numerators place and difference the common denominator. Determine critical points. The quotient will be 0 when the numerator is 0. The quotient is undefined when the denominator is 0. So the critical points, -2 and 6. Use the critical points to divide the number line into intervals. Above the numbers line shows the sign of each factor, the rational expression in each interval. Below the number line shown, sign of the question. Determine the interval where inequality is correct. It is the interval where less than 0, inequality less than 0. We want the quotient to be negative. So the solution includes the points between -2 and 6. Since the inequality is strictly less than, the endpoints are not included. So the solution of this inequality is interval notation as from -2 to 6. So a next example, solving this fractional rational inequality. Subtract this value on the right, both sides of this inequality to this number and get 0 on the right side. So rewrite to get each fraction with LCD and find common denominator. Factor the numerator is equal to this inequality. Determine critical points. They are x -1 equal to -1, 0, and 6. Using critical points, we divided the number line into intervals. Above the number line shows the sign of each factor rational expression in each interval. So we find the sign of this latest inequality on each interval. So below the number line shows the sign of the quotient. Since 0 includes the solution is 2 number intervals, so the solution of this inequality is intervals from -1 to 0 and 0 to 6. So as home task, you make these polynomial inequalities and rational inequalities. Of course, you may use this by using these examples. So that's all what I show you, say you. So thank you for your attention. Сонымен қысқаша бүгінгі сабағымызға тоқталатын болсақ, негізі қарастырамыз көп мүше түріндегі, яғни сызықтық емес теңсіздік шешумен бөлшек рационал теңсіздік шешуге келді. Бұл жерде екі жақтында да интервалдар әдісімен жаңа әдейі көрсетіп сайн чат дедік. Әрбір интервалдар әдісін мен шешу үшін біз critical numbers дейді. Кризис нүктелерін тауып аламыз да сандық оське белгілейміз дейді. Яғни бұл жерде critical numbers деп тұр. Сосын бұл critical numbers әрбір табылған критик нүктелерді сан осіне қоямыз. So put down each critical number into the number line. Берген критикалық нүктелерім сан осін 4 бөлікке бөлді деген. The critical number divided деуге болады, немесе partition the number line into some regions. 4 regions, 3 regions деген сияқты. Дәл сол сияқты бөлшек рационал теңсіздікті шешкенде де бізде дәл сол алгоритм сақталады. Тек қана ортақ бөлімге келтіру. Latest common denominator ортақ бөлімге келтіріп, сол бөлім нөлге айналдыратын шешімдерді тауып, яғни оның өзі бізде кризис нүктелерді беретін анықтаймыз. Яғни бұл жерде айтады critical points, the points where rational expression will be zero or undefined. Яғни кризис нүкте осы рационал өрнекті нөлге айналдыратын, немесе анықталмайтындай жағдайға айналдыратын нүктелерді айтамыз. Сонда біз алым бөлімін нөлге теңестіріп аламыз деген сөз ғой. Сосын әрбір аралықта осы кризис нүктелерімен бөліп алғаннан кейін әрбір аралықтағы мына теңсіздің таңбасын анықтаймыз дейді. Осымен сіздерге айтайын деп жатқан негізгі екі тақырыбым осы болатын. Тыңдағандарыңыз үшін рахмет. Сау болыңыздар.